Chapter 12, Surface Area and Volumes. This presentation on surface area and volume covers the following topics. An introduction on Slide 3. Surface area of a combination of solids on Slides 4 through 9. Volume of a combination of solids on Slides 10 through 12. A summary on Slide 13. Introduction. We are surrounded by objects of various shapes. Have you ever wondered how to find the surface area or volume of these objects? In this chapter, you will learn how to do just that for combinations of different shapes. Surface area of a combination of solids. Consider a solid made up of a cylinder with two hemispheres attached at either end. To find the total surface area of this new solid, you simply add the curved surface areas of each individual part. The formula is the total surface area of the new solid equals the curved surface area of one hemisphere, plus the curved surface area of the cylinder, plus the curved surface area of the other hemisphere. Let's consider another example, making a toy by joining a hemisphere and a cone. First, we take a cone and a hemisphere. For the toy to have a smooth surface, the radius of the cone's base must be equal to the radius of the hemisphere. When we bring their flat faces together, we get the final toy shape. The formula for the surface area is the total surface area of the toy equals the curved surface area of the hemisphere plus the curved surface area of the cone. Example 1. The playing top. A playing top, or latu, is shaped like a cone on top of a hemisphere. The total height of the top is 5 centimeters, and its diameter is 3.5 centimeters. Let's find the area that needs to be colored. We will use pi equals 22 divided by 7. First, the total surface area of the top is the curved surface area of the hemisphere plus the curved surface area of the cone. The curved surface area of the hemisphere is given by the formula 2 times pi times r squared. Plugging in the values, we get 2 times 22 divided by 7 times 3.5 divided by 2 times 3.5 divided by 2. Next, the height of the cone is the total height of the top minus the radius of the hemisphere. This is 5 minus 3.5 divided by 2, which equals 3.25 centimeters. With the cone's height, we find its slant height, L, using the formula the square root of r squared plus h squared. This is the square root of 3.5 divided by 2 squared plus 3.25 squared, which is approximately 3.7 centimeters. Now, the curved surface area of the cone is pi times r times L. This is 22 divided by 7 times 3.5 divided by 2 times 3.7. Adding the two curved surface areas together gives us a total surface area of approximately 39.6 square centimeters. Example 2. The decorative block. A decorative block is made of a cube with an edge of 5 centimeters and a hemisphere with a diameter of 4.2 centimeters fixed on top. Let's find the total surface area of the block, using pi equals 22 divided by 7. The logic is, find the total surface area of the cube, then subtract the area of the base of the hemisphere, since that part is covered, and finally add the curved surface area of the hemisphere. The formula is total surface area of the cube minus the base area of the hemisphere plus the curved surface area of the hemisphere. This simplifies to total surface area of the cube plus pi times r squared. The surface area of the cube is 6 times edge squared, which is 6 times 5 times 5, equaling 150 square centimeters. So, the total surface area of the block is 150 plus 22 divided by 7 times 4.2 divided by 2 times 4.2 divided by 2. This comes out to 150 plus 13.86 for a final total surface area of 163.86 square centimeters. Example 3. The toy rocket. A toy rocket is shaped like a cone mounted on a cylinder. Let's find the area to be painted. The conical part is orange and the cylindrical part is yellow. We will use pi equals 3.14. Here are the dimensions. Total rocket height, 26 centimeters. Cone height, 6 centimeters. Cone base diameter, 5 centimeters, so radius r is 2.5 centimeters. Cylinder base diameter, 3 centimeters, so radius r prime is 1.5 centimeters. Cylinder height is 20 centimeters. The slant height of the cone, L, is the square root of 2.5 squared plus 6 squared, which is 6.5 centimeters. Area to be painted orange, the cone. This is the curved surface area of the cone, plus the base area of the cone minus the base area of the cylinder. The calculation is pi times point. This results in 3.14 times 20.25, which equals 63.585 square centimeters. Area to be painted yellow, the cylinder. This is the curved surface area of the cylinder plus the area of its base. The calculation is 3.14 times 1.5 multiplied by 2 times 20 plus 1.5. This results in 4.71 times 41.5, which equals 195.465 square centimeters. Example 4. The bird bath. A bird bath is in the shape of a cylinder with a hemispherical depression at one end. The cylinder's height is 1.45 meters and its radius is 30 centimeters. Let's find the total surface area. We will use pi equals 22 divided by 7. The total surface area is the curved surface area of the cylinder plus the curved surface area of the hemisphere. The formula is 2 times pi times r times h plus 2 times pi times r squared. This simplifies to 2 times pi times r, multiplied by h plus r. Note that the height of 1.45 meters is equal to 145 centimeters. The calculation is 2 times 22 divided by 7 times 30 multiplied by 145 plus muppadu. The total surface area is 33,000 square centimeters, which is equal to 3.3 square meters. Volume of a combination of solids. Example 5. The industrial shed. A shed is in the shape of a cuboid, topped by a half cylinder. The base is 7 meters by 15 meters, and the cuboid's height is 8 meters. Let's find the volume of air the shed can hold. The total volume is the volume of the cuboid plus the volume of the half cylinder. The calculation is 15 times 7 times 8 plus 1/2 times 22 divided by 7 times 7 divided by 2 squared times 15. The total volume of the shed is 1,128.75 cubic meters. Now, if machinery occupies 300 cubic meters and 20 workers each occupy 0.08 cubic meters, for a total of 1.6 cubic meters, how much air is left? The calculation is 1,128.75 minus 300 plus 1.6. The remaining volume of air is 827.15 cubic meters. Example 6. The juice glass. A cylindrical glass has an inner diameter of 5 centimeters and a height of 10 centimeters. However, the bottom has a hemispherical raised portion, reducing its capacity. Let's find the apparent and actual capacity of the glass, using pi equals 3.14. The apparent capacity is the volume of the cylinder, given by pi times r squared times h. The calculation is 3.14 times 2.5 times 2.5 times 10, which equals 196.25 cubic centimeters. The volume of the raised hemispherical portion is given by 2 divided by 3 times pi times r cubed. The calculation is 2 divided by 3 times 3.14 times 2.5 cubed, which is 32.71 cubic centimeters. The actual capacity of the glass is the apparent capacity minus the volume of the hemisphere. This is 196.25 minus 32.71, which equals 163.54 cubic centimeters. Example 7. The solid toy. A solid toy is a hemisphere topped by a right circular cone. The cone's height is 2 centimeters and its base diameter is 4 centimeters. Let's determine the volume of the toy. Then, if a cylinder surrounds the toy, what is the difference between their volumes? We will use pi equals 3.14. The radius of both the hemisphere and cone is 2 centimeters. The volume of the toy is the volume of the hemisphere plus the volume of the cone. The calculation is 2 divided by 3 times 3.14 times 2 cubed plus 1 divided by 3 times 3.14 times 2 squared times 2. The volume of the toy is 25.12 cubic centimeters. Now, for the circumscribing cylinder, its radius is 2 centimeters, and its height is the sum of the cone's height and the hemisphere's radius, 2 plus 2, which is 4 centimeters. The volume of the cylinder is pi times r squared times h, which is 3.14 times 2 squared times 4, equaling 50.24 cubic centimeters. The difference in volumes is the volume of the cylinder minus the volume of the toy. This is 50.24 minus 25.12, which equals 25.12 cubic centimeters. Summary. In this chapter, you have learned how to determine the surface area of objects formed by combining basic solids like cuboids, cones, cylinders, spheres, and hemispheres. Find the volume of objects formed by combining any two of these same basic solids. Thank you for learning with us.